Welcome, everyone, and thank you for joining us for our kickoff event for Balluff's automation launch. My name is Chris Duncan. I am the trade show and event specialist for Balluff, and I will be your host for today's presentation. I'd just like to remind everybody, I know this is the kickoff event, so please, after this presentation, head over to the US Virtual Exhibition Room and check out the automation launch virtual exhibits. And our Balluff experts will be available with any questions that you have in that room. Today's presentation is Take Control of Your Downtime in 2021. And before we get going, we're going to do a few housekeeping items to enhance your experience. For the best viewing experience, please close any additional browser tabs you might have open or any additional programs you may have running in the background. The streaming live presentations is bandwidth intensive, so closing any unnecessary programs will help conserve your bandwidth. If you have questions, please use the Q&A chat box that is in the window here for Teams Live, and I will gather those questions, and after Will's presentation, we will have a Q&A session. And just know that if we don't get to everyone's questions or if we run out of time, I will capture all questions and we will respond to them through email after the presentation. If you are, if after the presentation ends, we will have our Balluff representatives in the exhibition room to answer any further questions you may have. And also, if you're viewing this in the future, please use the group chat. The contact me after this event button, and we will be able to answer your question via email after this. And I have copied and pasted a link to the box.com folder that has a PDF version of the presentation we're about to see. So if you would like to follow along with a PDF version, you can use that link there. And a replay of this presentation will be available after the presentation ends, and that will be on the same location that you use to access this in the virtual exhibition room in the on-demand page. Our presenter today is Will Healy. Will is Balluff's America's Marketing Manager, and Will is enthusiastic about smart manufacturing, automation, and STEM education. Will has graduated from Purdue University with a degree in mechanical engineering and has been sharing his passion for automation for 15 years in a variety of industries. He is published and quoted in various trade magazines, and Will was named one of 2020's emerging engineering leaders under 40 for Plant Engineering magazine. Will has presented on the value of sensors, IIoT, and networking at numerous trade shows like IMTS, FabTech, the Assembly Show, and many others. So without further ado, I'd like to present Will Healy and Take Control of Your Downtime in 2021, Condition Monitoring on a Budget for Existing Equipment. Will, take it away.
Thanks, Chris. You can hear me okay?
Loud and clear.
Perfect. So we're going to get started here with Take Control of Your Downtime in 2021. I know it's kind of one of those titles that you only can do in December and January, but that's okay. Really what we're going to talk about today is how we can do condition monitoring on a budget for existing equipment. And that's really what we're going to try to talk about today. So I want to get started with what are your goals. I really like to talk about and identify what's most important to you. Are you trying to improve asset utilization and machine availability? Maybe you're trying to shorten your planned downtimes, your setup times, and your changeover times. Or maybe you're trying to just stop fighting fires, less firefighting and more purposeful work. And how do we stop doing last minute bootstrap repairs? Maybe that's your goal. Let's not duct tape everything together, or I guess Gorilla Tape now. And then, overall, are you just trying to reduce unplanned downtime, small stoppages, nuisance stops, whatever you're trying to do? What are your goals and what's on your list? And I want you to think about those things and how this could apply to what you're doing. So the other thing I want you to think about is on what scale are you trying to do it? Are you responsible for a whole production facility at the plant level? Are you worried about plant health, the overall equipment efficiency, the OEE of the whole plant, the production levels of the plant? What are you looking to try to do? Next, are you trying to, maybe are you just responsible for a line or a production area or only one specific machine? Are you worried about the production output of that machine or the OEE of that piece of equipment? So maybe you have a different scale of objectives or goals. Or maybe you're just worried about one piece of equipment that's super annoying and really critical to what you're doing. And those critical pieces of equipment do typically provide clues before failure. Maybe you have that guy in your shop. He's been there for 50 years. And he can hear something walking down the aisle and know that, oh, that thing needs to get repaired or that needs to get tweaked. That kind of clue is there if you know what to look for and can find it. So the next thing I really want you to think about is with all those components, ask yourself, if this failed, would we be screwed? And if you think about that, there's probably a lot of components, conveyor motors or conveyor gearboxes, production equipment, or a pump that's pumping cooling water or cooling fluid. There's a lot of components that if they failed, we would be very screwed. So something to really think about. And here in the end, you have to really think about is you are only as strong as your weakest link. How many components and machines that you've purchased are past their service life? How many of the components in the manual say to replace every 5 years and you've been sitting on it for 10 years? The thing I want you to remember is if you do not schedule maintenance for your machines will schedule the maintenance for you. And that's something to really think about when you're looking at your equipment. What are your weakest links and how do we monitor those weakest links so they don't cause catastrophic events in our facilities? Today, the reason I bring all these things up is all of these topics can be impacted positively by condition monitoring. And this is really great. We have all of this equipment. We don't have to buy brand new fancy machines. It can be done with our existing equipment because the main problem in manufacturing is modernization is overdue. Automation systems are reaching the end of life, $65 billion of them. How many of us have spec'd a piece of equipment for 7 years and 20 years later, it's still on the production floor, right? We have lots and lots of equipment that's beyond service life. 4 in 10 manufacturers have no visibility into the real-time status of their manufacturing process. Maybe you have a whiteboard at the end where you write down the pieces after every shift. That's not real-time visibility into the status of your production. And only 50% of people are aware of a problem once it occurs. And that may seem obvious. Well, yeah, I don't know I have a problem until I have a problem. But like I mentioned earlier, you actually can get some hints and some clues that a problem is coming before the problem occurs and becomes a big problem. But the thing that I don't want you to feel upset during this presentation or disappointed with yourselves, only 12% of manufacturers think they're ahead of their competitors with their digital journey. And so everyone's trying to play catch up and everyone's trying to work on this right now. And so you're not alone thinking that everyone else is ahead of me. The real trick is downtime is killing us. And that's really the title of the presentation today. Taking control of our downtime. Downtime is killing us. Overall, this data from Industry Week, $17,000 per incident on average in their survey at Industry Week. 800 hours every year, according to a survey on an article by Garvey. So 800 hours every year, $17,000 per incident. And in a survey by ThomasNet, $22,000 per minute of downtime in the automotive industry. And at first you might balk at that. That's a crazy number, Will. But think about it this way. In Kentucky at Toyota TMMK, they make a Toyota Camry every 50 seconds. So every 50 seconds, a Toyota Camry comes off the end of the line. How much does a Toyota Camry cost? $30,000 starting. So $22,000 per minute actually isn't that surprising in the automotive industry when you think about it. And I know there's other industries like the oil and gas market where the downtime can be even higher. So a lot of this stuff also can be hard to reach. So, you've got pumps and motors and fans and drives. They might be inside a confined space or underneath the bottom of equipment or in a well or down in a basement or something like that, or inside the equipment, or someone has to crawl underneath the machine. That can cause a lot of extra paperwork and expectation to go in there. You have to get a procedural permit. You have to, there's a lot of effort to go into a confined space, or you've got to go way up high on the top of, this is a picture from the top of a crown of a stamping press. That's 3-4 stories in the air, right? I mean, you have major height topics. Maybe you have a fan that's up on the top of the building, or you have remote installations like a pump house might be out in a remote building that people only go to once a month or twice a month. So, we have remote installations of equipment. We have things that are high up out of reach. We have things that are in confined spaces, and we have stuff that's underneath equipment that's hard to get to. So a lot of this is hard to get to. So how do we monitor it easier and without having to enter those places or get to those places and all the safety requirements that go along with it? The thing I really want to point out, and the reason we're talking about condition monitoring, is we can detect failure before catastrophe. And that's really important to note. And I totally stole this chart from an article in ThomasNet, 4 practices for catching early signs of machine deterioration, but I thought it was such an interesting, good one to share with you. What we really want is we want more time to react and prevent functional failure, and we can do that with condition monitoring. So, when the deterioration starts on an asset, it can be a little bit hard to detect any issue. But there's a point P in this chart where we have potential to detect the failure. And as things go along, maybe by monitoring lubricant or monitoring vibration or monitoring pressure, we get into infrared thermography, humidity, noise, heat, smoke. If something's smoking, we're very close to failure occurring, right? If you see smoke or you have something that's hot, probably you're very close to failure. And so that interval from P to F, the P and F interval, what we want is we want to be able to detect and get the longest P and F interval we can, so we have the most time to react and prevent the functional failure with condition monitoring. I thought that was a really interesting article. So your competitors are investing in this. So if you think, oh yeah, these are fine, Will, these are interesting topics, but whatever. No, competitors are investing in this technology. Your competitors are, other manufacturers. From a survey from Control Engineering, the average IIoT budget is $328,000. And the main thing that we're spending money on is sensors. And the sensor budgets are growing about 15% a year, while network budgets are growing about 19% a year. So we're putting more sensors on machines and we're building more connectivity into our plants. And if you are not doing that, that's something to take very seriously. That $328,000 is average. 1/5 of those people have more than $500,000 for their budget, and they're buying these kinds of technologies to do this. Okay, so condition monitoring. Now what? There are some things to consider before I jump in here. There's lots of things that you have to think about. You have to really sit down and plan out what you're thinking about. Am I monitoring, we talked earlier, the plant versus the machine versus devices? Do you have periodic versus continuous monitoring? Predictive maintenance versus preventative maintenance? And then how do you connect it into your equipment? So that's what we're going to talk about next. So things to consider. The first thing to consider is, where are we going to do the monitoring? Are we most concerned about just an individual device or component, like on a motor? Maybe we're more worried about the machine and just overall vibrations on a machine, maybe, or vibrations on a piece of tooling like this die set here in a stamping press. Or are we worried about plant condition monitoring? So just overall, do we want to get a heat map or humidity map inside of our plant so we can get an idea where our hot spots or our high moisture spots if that's causing a problem for you? So where are we trying to monitor? What are we trying to monitor? The second thing that most people have to think about with condition monitoring, and you may already be doing some of this, is periodic condition monitoring versus continuous condition monitoring. And so on the left, you see an example of periodic monitoring. You have a little instrument, you put it on a bearing, you maybe use a smartphone or an app or a device, and you do a little bit of monitoring, and you do that once a month or once a quarter. That's periodic monitoring, but you just get a snapshot in time, right? So they might be doing periodic monitoring on the weekend when the equipment's not running or it's not running at full production, or you really have to be monitoring in real time to really get a clear view on your whole production process. And so continuous monitoring, like on the right, is a sensor that's permanently mounted to a device like this motor casing, and that can give you more information about the whole process all times a day, all production states, and gives you a continuous amount of information that'll help you make better decisions. But periodic monitoring can make sense if that works in a certain application or what you're trying to do. The next thing to consider with condition monitoring is, right now you're probably doing preventative maintenance. Every so many hours, lube this, or every so many hours tighten this. Those preventative maintenance applications are based on timing and the age and the use of the equipment. And the problem with preventative maintenance is preventative maintenance has an 82% random failure pattern. And so that can really be an issue for us, because you'll go and do a preventative maintenance and then literally the next day it'll break down. You think, I just did the preventative maintenance, right? So that can be a real challenge for us. So with predictive maintenance, the idea is we're going to use data, we're going to analyze this, and then we're going to employ condition monitoring and analytics to prevent failures. So we can improve uptime, we can improve asset longevity, we can get maintenance costs under control. And then we can really direct the specific activities of the maintenance teams and even prescribe what they need to do to have the most impact at the time. So the other thing that we have to consider with condition monitoring is connectivity. How do you want to connect to it? Is it distance really far away? Do you need a wired or a fiber Ethernet connection? Maybe wireless Ethernet or cellular. Proximity, how close, if it's close to you, maybe a near field might work if you're just doing, you're just doing some detection. Maybe near field with a sensor and a cell phone will work, or Bluetooth with a cell phone and a sensor will work. USB to a device or a computer that's on the machine, or even serial. I've seen some serial devices. But are you doing periodic versus continuous monitoring? That's going to have a direct impact on the kind of connectivity considerations that you need to consider. What I'm going to talk about today is a connectivity technology called IO-Link. It's a universal, smart, easy, and IoT-ready technology. It was designed and originally conceptualized as USB for automation. So the idea was to be easy to use, easy to connect, easy to plug together. And I know everyone says easy, but think about USB. The first time you went from using a parallel printer to a USB printer, it was way better, right? I mean, so much easier. And so that was the idea, and the concept here was to make it easy to get smart devices onto equipment. And what's cool about this is there are 200 plus vendors manufacturing IO-Link devices and thousands of products, probably tens of thousands of products at this time. So, there's a lot of opportunity for you to have devices and connectivity for this. So, and what's neat about IO-Link is it gives you visibility inside the device itself. So you get all kinds of diagnostic data on top of the control data that's available for running the process. So IO-Link is an interesting communication protocol that is not a network, but it allows you to get connectivity to smart devices in an intelligent way. So condition monitoring can be cool. We could talk about monitoring all these devices. If you remember that map at the beginning, monitoring all the components that might cause us problems. all you can think is that's going to cost me dollar signs, right? And we already did our budgeting, or my budget was cut because of the current situation. So, what can I do that's easy and inexpensive? And that's what I want to talk about today. What is something that you can do that's easy and inexpensive for a couple $1,000s with no monthly charges or anything like that? How can you get data and start monitoring the condition of your equipment inside your plant for a couple $100s to a couple $1,000, depending upon the scale of your project? So I'm going to talk about IO-Link Condition Monitoring Sensor. This is a brand new technology from Balluff. It's been available for a couple of months, but this thing is really slick. And stick with me through these couple slides. I've got 11 case studies, I think 10 or 11 case studies in my presentation that are going to show you all the real-world examples of people using this sensor. So I'm going to introduce you for a couple of slides here just about the technology and how it works so that you can really understand the applications when I get to the pictures of the applications. So what is condition monitoring? This is monitoring the status and health of the machines, the plants, or the individual components like bearings, linear drives, auxiliary units like compressors and fans. So monitoring the status and health of those devices. And this is continuous condition monitoring. It allows you to detect changes and anomalies and allows you to record long-term trends and do statistical evaluation of the status of the components. So again, I'm gonna talk about where we can do condition monitoring. We can do it inside a device. So we can do condition monitoring of a device itself, like a sensor. We can have monitoring sensors that monitor bigger devices like motors and compressors and fans. And then on the machine, we can mount a monitoring sensor on the machine to actually allow us to do that more. So the monitoring sensor can be used on components or on machines, but we can also monitor inside the device. So condition monitoring is available in a lot of IO-Link devices, like IO-Link power supplies or the photoelectric sensor you see down here. We can get information and condition of the environment and of the device, like the internal temperature or the signal intensity of the photoelectric light, the frequency of the switching, the operating hours, how many hours have we run, the lifetime remaining of the device. We can do calculations and tell you how much life is left in the power supply. The stress level, the two things that stress out electronics are heat and load. So is the stress level of the device high? And that's going to shorten the lifetime of the device. So we could tell you that. Light remissivity, signal stability, sensor LED power. The LED dies a little bit over time. So what's the strength of the sensor LED? If you have a short circuit, or what's the current draw of the power supply? There's lots of different things we can do inside a device. So those are the types of devices that we can utilize. And then also there's the option to monitor system pressure. System pressure is an interesting topic because, force is equal to pressure times area. So if we have changes in pressure, that can indicate that there are changes in your system, maybe more friction requiring more force for the movements that you're doing, maybe some slow leaks or issues with other components on the machine. So system pressure can be an interesting thing to monitor and to trend as continuous data to be able to get some insights. But what I'm going to focus on today, while we have the ability to look inside devices like sensors and power supplies, and we have the ability to monitor system pressure, what I'm going to focus on today is the condition monitoring sensor. So this brand new technology from Balluff, we can monitor multiple different measurement values with one sensor housing. This is vibration in 3 axes, temperature, ambient pressure, humidity. We're going to go in more detail in a second. It can do lots of data pre-processing with onboard calculations of statistical parameters. It can give you events and statuses, so like warnings and automated monitoring. You can set thresholds inside the sensor and then send outputs. And then you have the ability to change the process data that's most interesting to you. So there's lots and lots of data inside there, but having it present 5 different measured or calculated values back to the controller. And all this data comes over as process data to the controller, which is really powerful because that allows you to take it right in the controller, put it on an HMI very easily. Compact design, it's a very small form factor. It looks like a little flat pack Prox if you've seen that housing. So really small. It has a stainless steel housing, so if you're in the food and beverage market or you have wash down in a metalworking machine or cutting fluids in there, we have IP67 or IP69K depending upon the housing that you're looking for. And then there's an IO-Link interface. So I talked about IO-Link being universal and easy to integrate. The really creates for convenient integration into a wide range of technologies: Ethernet IP, Profinet, Profibus, DeviceNet, CC-Link, EtherCAT, Siemens PLCs, Allen Bradley PLCs, robotic end effectors, robot controllers. There's all kinds of things that we can integrate into because of the IO-Link interface. And then it has a standard M12 connector that most automation devices want. So when we look at the vibration module, I am by no means a vibration expert by any means, but here's some basic things that can be done with it. We can do vibration velocity or vibration acceleration, or get just the basic frequency. The key thing here is the sensor's designed to detect changes and anomalies, not necessarily to interpret the absolute measured value. So that's something to really understand. We're not an instrument here. This is a sensor to give some vibration information, but this has been very effective for many people monitoring vibration on this scale. And there's lots of calculations that can be done. You can see them there, and different severity zones, pre-alarms and main alarms, RMS values, and all kinds of things that can be done. So really interesting what you can do with vibration, and that's the main reason people are using it right now. You can also do temperature measurement of the surface, so the back of the sensor, whatever it's mounted to, gives you a measuring range of the temperature. And then one of the part numbers has a diaphragm here on the face of the sensor. It allows you to do humidity measurement as well as ambient pressure measurement. And so the ability to set events based upon humidity and ambient pressure can help in certain situations. And we'll talk about some applications for that in a few minutes in our case studies. So overall, this one sensor has many possibilities to do different condition monitoring applications, and it doesn't require any sort of additional specialized software or monthly subscription fees if you don't want them. No external diagnostic electronics, no complicated programming. The data comes as process data right into your PLC like any other sensor, and no complex interface because we're using IO-Link. So if you are interested in software capabilities, I've mentioned multiple times, the condition monitoring data is simple to integrate into most industrial PLCs and robot controllers. So it's very simple data that you can integrate. But if you're looking for someone to support with capabilities to provide condition monitoring custom software or portable condition monitoring solutions or remote condition monitoring applications, we have the ability to do that in the US, Mexico, and in Europe. So that is an option for you if you're looking for software capabilities and support with the condition monitoring. And we can talk about that. So where are places that people can use a condition monitoring sensor? There's so many places for potential failure in a plant. I'm sure you know them all intimately, probably on weekends and 3 o'clock in the morning. But worn bearings, worn belts, frictional rubbing, happens in a lot of places, unbalanced or soft foot, particle accumulation like on a fan blade or inside a device, inside a pump. Displacement, misalignment or collision with the device, and then any place where you have a remote room or a remote building where no one's watching it and no one's looking at it and no one's monitoring it. And then inside electrical cabinets, we have a really cool case study coming up here in a minute with electrical cabinets. But the goal is, where are you having machine downtime, and how could we monitor mechanical components? How can we monitor machines and the factory to increase the plant productivity? So do you have a spindle or a bearing or a pump or a gearbox or a fan or a switch cabinet where that is failing and that's causing headaches, and we need to look at that. So who's actually doing this? I promised you 10 case studies, maybe 11. Somebody keep counting, let me know how many it was. But here's some case studies. So the first is the chain conveyor drives. This case study, this customer has thousands of feet of chain conveyor with multiple synchronized drives. When one of the drives gets out of sync, the chain buckles, crashes, and causes major production downtime for them. So they are able to use the condition monitoring sensor to alert the maintenance with excessive vibration in the gearbox. And then they can perform a controlled shutdown and prevent a major crash. And this crash can cause days of downtime in this customer. So this is something that they take up very seriously, and the ability to alert ahead of time and perform a controlled shutdown is really a big deal for them. Here, anytime you have a unstaffed or decentralized pump house, right? Maybe you're pumping water from a well over to a building. You know, pumps are supplying lubricant, oil, water, other materials into the production process, you know, foodstuffs. So pumps can be everywhere and possibly in rooms or buildings that go on staff for days. So manual monitoring, which is what a lot of people do with these pumps, you know, someone's got to go out and manually do it. They got to document it. This can be time consuming and unpopular and questionably reliable. Did they do it on a continuous basis? Did we do it in a way that the data is reliable and usable to us? So continuous condition monitoring gives us that reliable and easy data to analyze when we need to analyze it in those remote and unstaffed or decentralized pumps. Here's an overhead crane. You know, you think about anytime you got an overhead crane that's way up in the sky, you don't want someone to climb up there and have to look at it or see what's going on. So if you can do condition monitoring up there, we can get data about what's going on with the equipment without anyone having to climb up there or get in a bucket and lift them up there. We can get the condition of those devices without anyone having to physically go into the overhead crane. And so this is nice because we've got controls up there. We have ways to connect this, and then we can measure the vibration and the temperature and of the motors and the components on the overhead crane. This is a candy factory. They wanted to implement a plant-wide monitoring program. So they had a corporate initiative to implement a plant-wide monitoring. They wanted to monitor dozens of locations and components on each candy molding line, temperature, humidity, vibration. And so by implementing a plant-wide system and monitoring multiple locations on the line, they now have a map of conditions of devices across the whole plant. And this has provided them with insights and helped them improve the OEE of the entire production plant. So this is a really powerful condition monitoring story with the ability to monitor all the different components and drives and conveyors and gearboxes across the pumps, across the plant to get a clear view of all the condition of all the devices across the plant. Here, this is a hydraulic stamping press, you know, maybe used for hot forming or hydroforming presses. So they're monitoring the temperature and vibration of the pumps and looking to see what's going on there. So they're monitoring the surface temperature of the pump and the vibration of the large hydraulic pumps. You see that thing, it's huge there. And they've got two different sensors on it in the left picture, and you can see it there in the power unit, and then it's running the press there. And so they can get the data without having to go down in the pit to look at that hydraulic pump. They don't have to go down in the pit to look at it and to do any condition monitoring. They get the data right in the PLC in the controller of the press. And so by using continuous condition monitoring of the surface temperature and the vibration, this has really given them a lot of value in their production process. Keeping on stamping presses. This is looking at press health. You know, they were having trouble where the press was getting damaged by the design of the dies that were being loaded into the press. And so the tooling was created excess shock from the snap through on some of the dies in the tooling that were loaded in the press and causing damage on the press. So by monitoring the peak and average vibration values during the run, they were able to figure out which were the hardest hitting tooling and comparing it to the tooling loaded to the shocks and the vibrations that they're getting. And then the die engineers were able to make modifications to the die sets and lessen the shock of the impact and reduce the press damage, which is really a compelling story if you think about it. That's really amazing. So you can see they're monitoring there on the top of the press, above one of the pillars, to look at the vibration and the condition of the press itself during the production process. This is an example. I don't have a picture of this one, but it is a customer story. They're monitoring, you know, ambient temperature, humidity, machine temperature, so that it can influence the product quality in the process. So by trending and monitoring the machine, they were able to increase their process reliability and reduce the production rejects. And so by monitoring that extrusion machine in a plastic injection molding environment, they were actually able to improve their process reliability. Here, this is a conveyor. It's a glass handling conveyor, and they were monitoring vibration velocity, the RMS for the X, Y, and Z axis, and the temperature. And the data goes, they don't actually run it into the controller. They're using Node-RED and a web service to actually run it straight into a server and to do analysis and reporting using Grafana. And so you see their reports here and their ability to trend the conveyor motors. They've got a condition monitoring sensor on both sides of the motor and monitoring the glass handling conveyors in the production plant. So this allows them to really monitor and know what's going on with the equipment and to create alarms if there's any overloading of the conveyor belts. And next is an automated assembly line. You know, anytime you have a highly automated assembly line, especially in tier 1 manufacturing for automotive, you know, there's lots of linear ball screws and rotary bearings and those kinds of things, and they're subject to mechanical wear and contaminants. And these things can fail just absolutely without warning. So replacement and repair of these can lead to long downtimes and cause issues with trying to get to them inside of a piece of highly automated equipment. So condition monitoring is provided for advanced warning for this customer and allowed them to schedule the maintenance during breaks and planned downtime. So it's been much more reliable for them because they've been able to monitor the bearing on the left side, the bearing on the right side, and the ball screw drive, and to get the condition data, the vibration data, the temperature data, and then create an advanced warning system so that they can do maintenance on their time and they can schedule the maintenance when they want to get it done. And then my second to last case study is a controls cabinet monitoring. You know, moisture, humidity, high temperatures inside of an electrical cabinet can really kill and destroy sensitive components and terminations. So if we monitor the humidity, the pressure, and the temperature inside the cabinet, if we monitor this over time, we can determine, you know, exposure rates. Especially in the food and beverage market, if you've got washdown situation, we could detect if a cabinet's left open, right? If the humidity level spikes, or if the cabinet's been sprayed inside during a washdown process, there's probably a pressure and humidity peak inside the cabinet, and even possibly a temperature peak. So by using a condition monitoring sensor, we can get an idea of what's happened inside the cabinet, especially in an environment with a lot of fluids and material like a washdown environment in food and beverage. And then my last application case study for you is a condition monitoring sensor used on a welding fume scrubber fan. So anybody who's doing welding, you probably have one of these welding fume scrubbers, right? It's pulling all the fumes out of the production area and scrubbing that and then sending it out through an exhaust. Well, when in these, you know, we can have buildup on the blades of the fan. And when the buildup and the particles in the smoke build up on the scrubber fan blades, this can cause excessive vibration and potential failure. In this specific customer, the loss of operation can cause 16 hours of downtime and require specialty hazmat maintenance personnel. And so it can be a very costly and very time-consuming repair when the welding fume scrubber fan goes down. And so you can see they added condition monitoring to this piece of equipment where they're monitoring the fan, they're monitoring the drive shaft and the gearbox, and they're monitoring the motor itself. So these are all pieces that they're monitoring, looking at the temperature, looking at the vibration, and really understanding if the bearing's overheating, or if the motor's overheating, or if the fan blades has excessive vibration. It probably means there's buildup on the blades. Let's do some scheduled maintenance and get that fixed. Really powerful opportunity for them to really improve their production and to reduce the downtime. Okay, so you want to get started with condition monitoring. That's something you're interested in. I found this really great article about what are the 4 condition monitoring steps, and I went round and round whether to use this or not, but to be honest, it's a really good plan. So I'm just going to share it with you. It's from an article in Control Engineering called Choose the Right Industrial Wireless Technologies for Condition Monitoring, but it doesn't even need to have to be wireless. They presented 4 condition monitoring steps, and I thought these were very powerful. So conduct a criticality analysis. So really what they're asking is, what assets have the most impact on the bottom line? And then identify the probable failures the asset will experience. So how has that asset failed in the past? What has happened to similar equipment or in your past work experiences with similar equipment? Third, decide on technology that's best suited to detect each failure mode. Can you just monitor the machine, or do you need to monitor the device? Does it need to be periodic, or continuous would be better? Can we get by with preventative on this, or do we want to get predictive on that? And then how are we going to connect it once we decide on the technology? And then last but not least, trend and analyze the data to plan and execute maintenance actions at the most advantageous times. And so what that means is look at all the data and use the data to tell us what's the best thing to do. So by reducing or by doing that, we can reduce the unplanned downtime and extend the life of the asset, which is really what we're trying to do, right? So how do you get started? I work with a lot of companies doing IoT projects, doing smart manufacturing projects, and doing condition monitoring projects like this. And the most successful organizations almost always follow a plan similar to this. They define their vision. What are they trying to do? What is their end goal? They set some objectives for the year. And then inside that year, they identify a few projects and tactics that they're going to try to implement. They make sure that they identify a couple of measurements, KPIs, key performance indicators, some things that are going to tell them, was it successful or not, so that they can document the success and they can feed that back in as a loop and say, see, this worked, give us more money so we can do more of it, right? So if we have those KPIs identified, which a lot of people forget to do, then it's much easier to ask for more money when we find that we're successful with this. And then last but not least, assign someone responsible. I always say if it's not someone's job, it's no one's job. Or if it's everyone's job, it's no one's job. So it's got to be somebody's job to work on these projects. What we've also found is when making changes to a maintenance program, it really is best to start with a small pilot. Grow it over time. Don't try to change your entire production plant at once. So start with a small pilot, create buy-in with the maintenance teams and the leadership team. It should be a joint project between the maintenance teams and the leadership teams. People should be working on both teams towards this project. We want to document those positive impacts, those KPIs. How did it help? What did it do? How did it save you? And then grow it over time using that documentation. Condition monitoring provides warnings about faults and makes it possible to schedule repairs all without unplanned downtime and lost production. And so really, by getting those warnings, we can schedule repairs, we can eliminate unplanned downtime. So condition monitoring really does help reduce downtime. You saw lots of different ways that can work in different production facilities and will guarantee you hit your 2021 goals. That's the will guarantee that condition monitoring will help you if you implement it. So what are you trying to do again? Are you improving asset utilization and machine availability? Are you shortening planned downtimes, setup and changeovers? Are you trying to stop fighting fires? Condition monitoring absolutely helps with that and doing those last minute bootstrap repairs. And then, we want to reduce unplanned downtime, the small stops, those things, and condition monitoring absolutely can help that and improve those asset utilizations and machine availability. So what next? What do you want to do? Ask yourself right now, do you want to learn more about condition monitoring? Is that something you want to do? Maybe you want to discuss how to implement your first pilot. Maybe that's interesting to you. You're convinced you want to do a pilot, or are you just interested in more best practices for reducing downtime? Maybe condition monitoring, you aren't there yet already. We've got a lot of great ways to talk about reducing downtime, not necessarily condition monitoring, ways to do it in welding and stamping and metalworking and assembly automation applications and manual assembly applications and food and beverage and in packaging and life science, all these different markets. We've got great best practices that we can share with you for reducing downtime. So if you want to do any of those three things, let's connect for a direct chat to talk and work on more details. Send me a text message right now. Send me a text. Or connect. And I share a lot of these case studies right in LinkedIn. If you want to see more examples in the future, follow me on LinkedIn and you can see more examples there. So that's my presentation. Thanks so much for spending your time with me. I'm going to turn it back over to Chris for a few final announcements.
Great, thanks, Will. Thank you very much for that presentation and sharing all that with our viewers. Right now, we're just going to have a Q&A session. So, Will, I got a couple questions in the chat. If anybody else has any questions, please submit those now, and we will answer those. And if we run out of time, just know we'll still capture those questions and respond to you after the presentation. So, Will, the first question that I have is someone is asking, is this available in Ethernet IP?
Yeah, good question. So I kind of sped through that, but I can be a little more clear. With this available with IO-Link communication protocol, but IO-Link works in a master device situation. So you have a device that talks to the Ethernet, and then you have a cable that connects to the device. And so yes, you can connect it to Ethernet IP. You do it by using that kind of hub, that master device, and you connect it to the sub device, the condition monitoring sensor into that master device, and that master talks Ethernet IP. That has a lot of advantages. If you're interested in talking about that more, connect with me and we can talk about the advantages of IO-Link specifically and how it can get multiple different technologies, not just condition monitoring, onto Ethernet IP. It's very widely used that way with IO-Link and Ethernet IP.
Great. Let's see, I have another question here for you, Will. Someone from Sean, it says, how does Balluff's condition monitoring sensor compare to instruments that you can buy from companies like Fluke?
Yeah, fair question. Yeah, so this is not an instrument. That's a really good question. You know, there's a lot of like really high-end instruments that can be used with like Texas Instrument monitoring, and this isn't that level of instrumentation. This is a sensor. The idea is to be able to monitor and look at the condition of the device, and it does a very good job of that. But if you are trying to really get super detailed and nuanced in information, instrumentation can definitely apply in certain applications. So I'm not a vibration expert by any means. I'm trying to get there, but you know, there's a whole industry in vibration monitoring with instrumentation, and this is more on the sensor level. So I would say low end and instrumentation is high end. So the price points also match in that situation as well. The condition monitoring sensor is a very reasonable price, and so it's a good entry level tool, especially if you already have automation on your machine. It's an easy integration into the existing PLC and the existing equipment.
Great, good. Thanks, Will.
Any other questions there, Chris?
Looks like that's all we have right now. Yep. So yeah, if anybody thinks of any other questions, please connect with us, and we'll be able to answer that after the presentation.
Great.
So I just want to go ahead and again say thank you very much to Will. If you have any further questions, please use the US exhibition room in the group chat to be able to connect with our experts. And Will, our presenter, is actually going to be stationed there for this afternoon and as well as Thursday afternoon. So please feel free to connect with our presenter, as he said, on LinkedIn. So if you missed that slide there, here that information is again. And then also there is his email address as well. So please feel free to connect with us. And please take time to visit our US exhibition room on the virtual platform. We have a lot of great exhibitions that can answer a lot of questions and make sure that you are prepared for 2021. We have Balluff experts on hand that can answer any questions as well. So in closing, I just want to say thank you again to Will Healy for sharing this presentation with everyone. And thank you for your attention, and I hope that you enjoyed the presentation, and I hope that you will enjoy Balluff's automation launch this week. I will leave everyone with the remaining live presentation schedule that you can access the same way that you access this. You can see the remaining presentations this week. Be sure to check those out, and please chat with our experts and let us know how we can help you be prepared for 2021. Thank you.